Okay. Right. You see the screen, Ashraf?
Yes.
All right. Okay. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all my friends, especially Dr. Asma. So for today, EMM4412 Advanced Material, my friend Asyraf Sukri and I, Muhammed Danial Syazani, will share with all of you regarding the topic electronics materials. Interesting, right? Okay, so let's move to the topic outline. At the end of this presentation, students should be able to understand the influence of temperature and impurities toward resistivity of metal, determine the resistivity and electrical conductivity, discover about charge carrier in insulator and also semiconductor, compare between insulator, conductor, and also semiconductor. Alright, so without wasting any time, let's start with our subtopic, our first subtopic, which is influence of temperature and impurities on resistivity of metal. Basically, presence of imperfection increase resistivity. What is resistivity? How can it cause the increase in resistivity? Basically, source of imperfection can come from grain boundaries, dislocations, vacancy, and impurities of atom, as you can see in figure below. This imperfection will increase the resistivity by making the electron scatter around and make it less direct path. Alright? So, resistivity can increase with increase in temperature, percentage of impurity, and also percentage of concentrations. Basically, as you can see in figure 18.8, we can see that resistivity resistivity can be concluded by the p-thermal resistivity impurities and addition of resistivity deformations. All right, so basically the unit of resistivity is 10 to the power of 8 ohm meter. All right, so let's move to the interesting part, which is estimating conductivity, the calculating part, which is good to be practiced in our daily life, especially in exam, right? Okay, so the question asks us, estimate the electrical conductivity of copper nitride alloy that have a yield strength of 1 to 5 megapascal. What we are going to do, how to start? Okay, so the first step is find the concentration of nickel by using the figure 7.16p on my hand side. So from the figure we can obtain the value of concentration of nickel is 21%. All right, by we just plotting this graph and we get the answer. Then the second step is to find the resistivity by using the figure 18.9, where the value of the concentration we just plot to the graph and we get the value of resistivity is 30 to the power of negative 8 ohm meter. So the last step, we need to find the electrical conductivity as asked in the question. So the formula of electrical conductivity is 1 over the resistivity, and we get the answer is 3.3 to the power of 6 ohm meter. Okay, so I will pass to my friend Asyraf to continue about the charge carrier in insulator and also semiconductor.
Right.
All right.
Where are we present now? Okay. Can you see my slide?
Yes.
Can you see my slide?
Yes. All right.
Okay, thank you to the Syazani. Now I will proceed to the electronics material. Yeah, I will present about the charge carrier, insulator, and semiconductor. So, uh, as a figure 8.6 below, you can see the arrangement of the electron, free electron excitation, and hole in a valence band. So in the electronic charge carrier, we have two types, which is free electron and hole. Okay. The first one is the electron, free electron. Okay, free electron it have a negative charge. So the free electron is placed in the conduction band. Conduction band. So for the hole, for the next type, which is the hole is a positive charge. So the hole is located at a valence band, which is okay. The hole is a vacant electron state in a valence band, like you said. Okay. So then we proceed to the okay. The charge carrier, move at a different speed. So the two type of the holes and the free electron have a different speed of a different speed and different speed, which is drift velocity. So so in a physics, a drift velocity is an average velocity attained by the charged particles such as electron in a material due to electric field. So drift velocity is a proportional to the current. So in the resistive material, it also proportional to the magnitude of an external electric field. Thus, Ohm law can be explained in terms of drift velocity. So we can see that U is equal to the drift velocity, mu is the material electron mobility, and E is the electric field. So here the equation, so here we can derive the equation which is U equal to mu E. So then we proceed. Okay, then after we know all the information that we wanted about the drift velocity, so now we proceed to the calculation of drift velocity. So the question said that the calculate the drift velocity of electron in copper 12 gauge copper wire, which is have a diameter of 2.053 millimeter, carrying 20 ampere current. So given that there is a one electron, free electron per copper atom, so which is inside the copper wire, it has one free electron per copper atom. So however, wiring of often contains 12 gauge copper wire, and the maximum current allowed in such wire is usually 20 ampere. Okay, for the density of the copper is 8.8 multiplied by 103 kilogram per meter cube. So then, okay, for the first step, we must find the density of the free electron, copper. So we know that we gain the information from the question that we have one free electron per copper atom. So then we find the okay, therefore is the same as the number of copper atoms per meter cube. So we gain that the density of the free electron in a copper is 8.342 multiplied by 10 to power of 28 electron per meter cube. So then the second step to find the drift velocity is calculate the cross-sectional area. Like the question state below, the question state below that uh, the cross-sectional area, the diameter of the wire is 2.053 to the power of 10 negative 3 meter. So we must find the cross-sectional area, which is the formula is area cross-sectional area equal to pi r square. So the cross-sectional area is equal to 3 and we substitute the value inside the formula, and we get the cross-sectional area of wire is 3.310 multiplied by 10 to power of negative 6 meter square. Then the last step is we rearranging the formula of the current. So we see the current is equal to the density of free electron multiplied by the constant, multiplied by the cross-section area, multiplied by the drift velocity. So from here we can find the drift velocity because we already find the value for the density of the electron and the cross-sectional area, and we have already have a constant value. So after we derive the equation, we get the drift velocity equal to current divided by the density of free electron, constant, and cross-sectional area. So the value of drift velocity that we get after we substitute the value that we gained from the previous step. So is a negative 4.3 multiplied by 10 to power of negative 4 meter per second. So then, so the minus sign here indicate that the negative charge are moving in the direction opposite to the conventional current. Okay, then we will proceed to the comparison between the conductor, insulator, and semiconductor. So we have four characteristics. So here, for the electric conductivity, so we know we have a three type, which is conductor, insulator, and semiconductor. So the conductor is have a good conductor compared to insulator, which is a bad conductor. So, however, the semiconductor is work differently because at a 0 Kelvin, which is 273 Celsius, it works as an insulator, while by applying the thermal agitation or by adding the impurity becomes good conductor. So the second one, the charge carrier. So what the three type is carry inside in their how they carry. So what is the carry? So sorry. So the conductor carry the electron, but the isolator they do not contain any charge carrier. So for the semiconductor is have an intrinsic charge carrier, which is holes and electron. Uh,
All right, that's true, Ashraf. Okay, so I will continue about the number of charge carrier. Basically, we can see from the figure the number of charge carrier in semiconductor is low, while in the conductor is high, where the insulator is negligible. And the current flow in conductor, we have a current flow due we have the charge carrier electron, while insulator there's no current flow. Why? Because they do not contain any charge carrier, so that current cannot flow. And for the semiconductor, the current flow due to hole and electron, as mentioned in the charge carrier with intrinsic charge carrier. All right. So, Bob, Ashraf, continue.
all right. So we jump to the end. So the conclusion is so we can conclude that the imperfection increase resistivity that the interaction increase the resistivity that will increase the electrical conductivity. Besides, the charge carrier consists of the positive and negative, which is the hole. We know that positive is hole and negative is free electron that move with different speed along the insulator and semiconductor. So, okay, here the references that we use for our slide and our presentation as our reference. So, I think that's all from us. Thank you.
All right. Thank you. Have a nice day and selamat menyambut Hari Raya. Okay, bye. Thank you,
Bye.
Ashraf.